In this video, we'll look at graphs and tables of linear functions in order to explore what makes a linear function linear. We'll be using the Desmos graphing calculator. A linear function in slope-intercept form can be written as an equation, or it can also be shown in a table. Let's use the Desmos graphing calculator to do this. Start by creating a Desmos window. You may want to log in. Input the function f of x equals mx plus b as shown here. F of x equals mx plus b. You'll be asked if you want to create sliders for m and b. You do, so click the All button. You will see sliders for m and b. Change their values to see the effect on the graph. For now, set m equal to 1 and set b equal to 0. You can also create a table of values for this linear function. Click on the plus sign and look for the table icon and click on it, like this. By default, you'll see x1 and y1, but we want to link this table to the function we just created. Replace x1 and y1 with x and f of x as shown here. Change x1 to x. Change y1 to f of x. Now input values for x in the table starting from 0 to 3 in equal increments, like this. 0, 1, 2, 3. You'll see that the program automatically calculates the values for f of x, along with the graph of those points. Notice how the points are equally spaced. As x increases by 1, y also increases by 1. Click and drag on the slider for m to increase its value. Notice that as m increases, the distance between the points also increases, but the points remain equally spaced. Do you see that? Move the slider for m so that m is equal to 0. Here you see the points are 1 unit apart. Now increase m to m equals 1. Although the points are equally spaced, they are also farther apart. We can use the distance formula to see how the distance between the points change as the slope changes. Start by inputting this set of coordinates as shown for x coordinates a and c. Input a and f of a, and c and f of c. Create sliders for a and c. Click on Label, change the value of c to c equals 2. Points A and C are the purple points. Let's find the distance between these coordinates. Use the distance formula as shown here. The distance formula is the square root of these expressions, the difference between the y-coordinates squared and the difference between the x-coordinates also squared. So input this expression. The square root of f of c minus f of a quantity squared plus c minus a quantity squared. Next, move the distance formula so that it's right next to the slider for m. Go back to m equals 0. Here you can see the distance between these 2 points is 1. Now increase the value of m to 1. Then to 2. See how the distance between these 2 points keeps increasing as the slope keeps increasing? The points are still equally spaced, which is a property of all linear functions, but the distance between the points changes. What this means is that slope is the rate of change. You will see many real-world phenomena modeled by a linear function, and the slope represents the rate of change. For example, a linear function can show the relationship between distance and speed, where speed is represented by the slope. As the speed increases, the distance traveled increases.